Welcome to Cambridge Chemistry channel with sarwtahmed. Be sure to like the video and subscribe the channel. It really helps the channel to grow. In this video I will discuss titration question of 9701 3-4 October November 10. Question number 1. FB1 is an aqueous solution containing 21.50 gram per dm cube of mixture of iron 2 sulfate and iron 3 sulfate. FB2 is an aqueous solution containing 2 gram per dm cube potassium manganate. In the presence of acid, the iron 2 sulfate is oxidized by potassium manganate. So this is the redox titration, and you know that iron 2 salts act as a reducing agent, potassium manganate act as an oxidizing agent. Potassium manganate oxidized iron 2 to iron 3. So this is the chemical equation of redox reaction method. Fill a burette with FB2. FB2 is an aqueous solution of potassium manganate. So burette is filled with FB2. Pipette 25 centimeter cube of FB1 into the conical flask. FB1 is the iron 2 salt, FeSO4, and Fe2SO4 thrice. This is a mixture of FB1 is a mixture of iron 2 sulfate and iron 3 sulfate. Use a 25 centimeter cube measuring cylinder and add 10 centimeter cube of dilute sulfuric acid to the flask. So sulfuric acid is added due to the for acidification of this salt. So next, place the flask on a white tiles. Why on white tiles? To for accurate color change. White tile is used for to measure the accurate color change. Carefully titrate with FB2 until the first permanent pink color is obtained. You should perform a rough titration. So this is the rough titration. Make a suitable table like this. Final burette reading centimeter cube. So this is very important to draw neat and clean with correct labeling of the table. So unit is also very important, carrying 1 mark for every burette reading. Place the unit of the volume of the liquid. Final burette reading centimeter cube, initial burette reading is centimeter cube, volume of FB2 used centimeter cube. So 26.20 is the final burette reading, 0.00 is the initial burette reading, and 26.20 by subtracting this we get volume of FB2 used in this experiment. So this is the rough titer, 26.20 centimeter cube. Carry out as many accurate titration as you think necessary to obtain consistent results. Record a suitable form below all of your burette readings and the volume of FB2 added in each accurate titrations. Make certain any recorded results show the precision of your practical work. Final burette reading 26.40 and 0.50, 25.90 is the volume of FB2 used. Okay. So this table carrying 1 mark, drawing the table carrying 1 mark, unit and precision of the unit and correct labeling of the burette reading, like final burette reading carrying 2nd marks, units carrying 3rd marks, and pattern of the reading and correct subtraction carrying 4 marks. 5th marks is the trend of the volume of FB2 used. So and 6 marks is the consistent result. 6 and 7 marks for consistent result if the difference between 0.1 to 0.2 between the two best titration, that is the carrying 6 and 7 marks. So this is the table 26.40, 41.2nd titration reading is 41, and this. So by subtracting this 25.90, 41.00 minus 15 to form 26.00, and this is 26.20 and 26.0. So these two readings are the consistent or best titration because there is no difference between the volume, exact 26 centimeter cube of FB2 and 26. So these are the two best titrations. So your reading difference should be 0.1 to 0.2. So this is the best. These are the two best. If not equal readings are there, so if there is the difference between 0.1 to 0.2, so those readings are consistent reading or best titration reading. From your accurate titration results, obtain a suitable value to be used in your calculation. Show clearly how you have obtained this value. So these are the two best titration. So by using adding these two readings and divided by 2, we get the average titer reading. So this is the 26.00 volume of FB1, 25 centimeter cube of FB1 required, 26 centimeter cube of FB2. Calculation: show your working and appropriate significant figures in the final answer to each step of your calculation. C1, calculate the concentration in mole per dm cube of the potassium manganate. So first convert, because the concentration of potassium manganate is given in gram per dm cube, so first convert into mole per dm cube. So this is the formula. We know that mole is equal to mass over mr, and mole per dm cube is equal to gram per dm cube of the mr. This is the formula how to convert gram per dm cube into mole per dm cube. So we have gram per dm cube, so this is gram per dm cube divided by mr of potassium manganate. So mole per dm cube, this is 2 gram is the mass, divided by mr is 150, 8 is the mr of potassium manganate, so we get 0.0127. The concentration of potassium manganate 7 in FB2 in mole per dm cube. Part 2, calculate how many moles of potassium manganate were present in the volume calculated in B. Concentration, we know that we have calculated earlier in the previous step, that concentration is 0.0127 mole per dm cube and the volume is 0.0260 dm cube. So this is 26 centimeter cube convert into dm cube, like 26 we have volume 26 centimeter cube, so divided by 1000 to convert into dm cube. So this is 0.0260 dm cube. The concentration mole is equal to concentration into volume. 0.0127 is the concentration and 0.0260 is volume in dm cube. So in this way the mole is 3.30 into 10 raised to minus 4 mole of potassium manganate. Calculate how many moles of iron 2 sulfate reacted with potassium manganate 7 in 2. So by using mole ratio, we know that in chemical equation potassium manganate has 2 mole and iron 2 sulfate is 10 mole. So 2:10 and 1:5. So this is by simplifying 2 1 the 2 2. So in this way, by simplification 1:5 is the mole ratio and the moles of potassium manganate ratio x of the iron mole. So in this way we get iron mole, that is equal to 1.65 into 10 raised to minus 3 mole of iron 2 sulfate reacted with the potassium manganate 7. Next part is calculate the concentration in mole per dm cube of iron 2 sulfate in FB1. So we know that the mole is 1.6 into 10 raised by 2 minus 3 and volume is 0.0250 dm cube. So this is we use initially that 25 centimeter cube is that is the volume of FB1 in the conical flask. 25 centimeter cube of FB1 is used. So to convert into dm cube, that is equal to 0.0250 dm cube. So concentration is equal to mole over volume. 1.65 is the mole into 10 raised by 2 minus 3 and divided by volume is 0.0250. So we get 0.0660 is the mole per dm cube. The concentration of FB1 is 0.0660. Calculate the concentration in gram per dm cube. This is very important because commonly such conversion is asked in the paper 3 examination. So it should be very clear that mole per dm cube is equal to gram per dm cube over mr, and now the concentration is in mole per dm cube. To convert into mole per dm cube is equal to, this is the formula, gram per dm cube is equal to mole per dm cube into mr. We have mole per dm cube is 0.0660 mole, and the mr of iron 2 sulfate is in FB1 is 151.9. So this is the concentration of iron 2 sulfate in FB1, 10.0250. So by using appropriate significant figure, we use FB1 contain 10.0 gram per dm cube of FeSO4. So you know that over here the gram per dm cube for significant figure is over here. This is given 2.00 gram per dm cube. So can use FB1 contain 10.00 gram per dm cube of FeSO4. FB1 is an aqueous solution containing 21.50 gram per dm cube of FeSO4 and Fe2SO4. Calculate the percentage by mass of iron 2 sulfate in this mixture. We know that this is the concentration in gram per dm cube of iron 2 sulfate in FB1 divided by, this is the 21.50 gram per dm cube of FeSO4 and Fe2SO4 thrice. So 10 over 21.50 into 100. So this is equal to 46.5%. The mixture contain 46.5% of iron 2 sulfate contained. So this is all about of this question. Hopefully you understood. If you understood this question, please like the video and subscribe the channel. Okay, Allah Hafiz.